Hello everyone, in this video I'm going to discuss the curve sketching. So we will do that through this given example. So we're going to sketch the function fx is equal to 3x raised to power 4 minus 4x cube. So we start with finding few important points on the function. So first we're going to talk about the roots of the function. So in order to find the roots of the function, we set fx equal to 0 and we solve this equation for the values of x. So this implies 3x raised to power 4 minus 4x cubed should be equal to 0, and from here x cubed is a common factor, 3x minus 4 should be 0, and from here since the product is 0 it means either x is 0 or x is 4 over 3 because 3x minus 4 is 0. So we got two roots of this function. So that means these are the two points where the curve gonna cross the x-axis. Next, we're gonna find the critical values of this function. So critical values are the values at which the first derivative is 0 or first derivative is not defined. So in this case, so let's take the first derivative. So first derivative of given function would be 12x cubed minus 12x square. So let's set this equal to 0. So this equals to 0 implies 12x cubed minus 12x square equal to 0, which in turn implies, so 12x square is a common factor. Inside we are left with x minus 1. So either x is 0 or x is 1. So these are our critical values. Now we're going to use the first derivative test in order to find whether these critical values are the point of maxima, minima, or the inflection point. So if you are more concerned about first derivative test, please refer to one of my previous videos, which is named as first derivative test introduction. For first derivative test, we set up the table. So we write the critical values, so 0 and 1 here, and then we're gonna look for the signs of the slopes and also the behavior of the function, whether it's increasing or decreasing. So we're gonna choose some points to the left of critical value. So let's choose, so left of 0 would be -1, a point to the left of 1 would be half, 0.5, and then a point to the right of 1 we can choose 2. So now we're going to decide when we put x equals to -1, what is the value of slope. So this is our slope function. So the derivative, right? So if you put x equal to -1, so you're going to get a negative slope. So we get negative. If x is equal to half, again, we're going to get a negative answer. And if x equals to 2, we're going to get a positive slope. So based on this, we decide that when slope is negative, the function is decreasing. When slope is negative, the function is decreasing. And when the slope is positive, the function is increasing. And since when there is no change in the sign of the slope, so it is always decreasing. So this is our, so x equal to 0 is our inflection point. Inflection point, no change in the slope, it's so continuously decreasing. And for x equals to 1, so since the function changes from decreasing to increasing, so we get a point of minima. So point of minima, local minima. So inflection point is a point where the concavity of the function changes. And at x equals to 1 we get our minimum value. So the minimum value of the function would be, so value of the function when x equals to 1, so our function was this, so we get 3 times 1 raised to power 4 minus 4 times 1 cube, so 3 minus 4, which is -1. So that is our minimum value of the function. So that's the local minima. So one thing I would like to point out, so if you're looking for the inflection point or if you want to talk about the concavity, so inflection point, uh, the required condition is that second derivative should be 0. So you can always figure out the second derivative of the function and see at what points it is equal to 0. So in this case, if I take the second derivative of the function, so I get that x should be either 0 or 2 over 3. So these are two possible inflection point, and we already know that x equal to 0 is inflection point for sure. So another inflection point might be 2 over 3. So when we draw the curve, we gonna keep these things in our mind. Let's try to graph our function with the given information now. So first we know about the roots. So roots are at the point 0 and 4 over 3. So when roots is x equal to 0, so y is 0, and also when x is equal to 4 over 3, so it would be somewhere in the middle of 1 and 2, but more on the one side, so it would be 4 over 3 again. At that point, we have y value 0. So these are our two roots. And from our this table, we know that the function is going to be decreasing from 0 to 1. So it means function is decreasing because the slope is negative here and function is decreasing from negative infinity to 0. So we draw something like decreasing function here. And then between 0 and 1, again the function is going to be decreasing, but we also found that another inflection point is at 2 over 3. So the concavity going to change at 2 over 3. So thus the function is going to be decreasing from negative infinity to 0, and then also going to decrease from 0 to 1, but there is a possible inflection point at 2 over 3, and also there's an inflection point at 0, right? And then it's going to attain the minimum value at negative 1, 1, negative 1, and then it's gonna start increasing. So after 1 it starts increasing, and then it crosses the curve. It crosses at 4 over 3 because that's another root, and then it starts increasing from there on. So this is what roughly our curve looks like. So that is our curve sketching. I hope that makes sense, because this point is going to be so 2 over 3 and some corresponding y value. So that's our possible inflection point, the second one. So that's why there is a little tint in the curve because it changes its concavity here. So that gives us a rough idea of our sketch. So this is how we do the curve sketching. So we find the roots, we find the critical values, we figure out the intervals where the function has negative slope, where it has positive slope. Based on that, we decide where it's gonna increase or decrease. And in the end, we try to draw our curve based on that information. I hope that makes sense. Thanks for watching this video. If you like this video, please hit the like button and subscribe to my channel. See you next time.